It's okay. We can just get some stuff we might be missed.
Yeah. Okay. Great. Thank you for coming. So today we're going to be doing chi-square distribution. So we're going to split the section into two. The first half of the session, we're going to look at goodness fit of test, and then we'll have a break, and then we take the second session, we will look at the contingency table, which is chi-square for independence. And because we're testing something, so we will have to use the hypothesis testing method because we need to prove that one view is different from the other. By the end of the session, you should be able to know how to do hypothesis testing and know how to use and when to use the chi-square test for goodness fit test, and later on how to use the chi-square test for independence. So now let's learn what goodness fit test is. A goodness fit test is a method of testing whether the selected sample fit a certain pattern or a certain distribution. So for example, you have the prices of rice in a store and you want to see if the prices every month they fit a certain distribution. So you will take the price of rice and run the hypothesis testing. So for example, the hypothesis testing, we know those 6 steps of hypothesis testing. So we're going to state what your null hypothesis will say. You will state that it fits the certain distribution, and then you go into calculate your probabilities. And because we're using the month, it's easy to calculate those probabilities. Then you're going to calculate your expected values. Then you calculate your test statistic, and then calculate or find your critical value, and then make your conclusion. And that is the pattern that you're going to do in order for you to test that this sample fits this given distribution. Another example, we use this method to test or to see whether the birth of children are evenly distributed throughout the year. Or another example, you can use it whether you want to see if for a given sample of people that it fits a general pattern or a general age distribution pattern. And this method can also be used to test the fairness of a coin, because when you toss the coin, you want to see how many times it rolls on a head, or sorry, when you roll a die, not to roll a coin, when you roll a die, you want to see if it falls on 4 or 1 or 6, and so forth. Or when you toss a coin, you want to make sure that that coin is fair and it will land on a head or it lands on a tail. When we state the null hypothesis for goodness fit test, we always going to state it that the population fits the given distribution. Therefore, it means you cannot say anything else other than saying the population fits the given distribution. It's very important. The alternative will state the opposite. It will say the distribution does not fit the given distribution, or the distribution does not follow a given distribution. To test the hypothesis, we also need to calculate the test statistic. To calculate the test statistic, we use the chi-square test statistic, which is the sum of your observed value minus your frequency squared divided by your frequency. Your observed value will be those prices that you are given. You will be given that, and the expected frequency is the calculated value. So sometimes they will give you the probability. If they do not give you the probability, therefore they will give you things that will make it easy for you to calculate those probabilities. For example, like a calendar with months. If it's a monthly thing, we know that we can use the month to calculate the probability for every month. So we know in January has 31 days. We can calculate the probability for January. February, if we use a normal 365-day calendar, then we can say we don't consider the leap year. So February will have a 28-day, and we'll say 28 divided by 365. March will have 30 days, so it will be 30 divided by 365. And those will be your probabilities for all the months, depending on how many days that month have. And then once you have calculated those probabilities, or they have given you the probabilities, then you just need to take those probabilities and multiply them by the grand total to get the expected value. And I will show you later on how to calculate this expected value. Then you will need to go and find the critical value, because you will take the test statistic and make a decision out of it. So when we go find the critical value, our critical value is given by the degrees of freedom, which in this instance, it will be the your number of cases that you will have. So for example, once you have your degrees of freedom, because we only have one row, so it will always be 1, and it's 1 row and how many columns. So it's number of rows multiplied by number of rows minus 1 times number of columns minus 1. And once you have your critical value, you should be able to make a decision. Making a decision, for me, it's easy when I draw the graph than to always know or remember the decision rule. But the decision rule says if the test statistic is more than your critical value, then we reject the null hypothesis. But clearly, if we draw the graph, you should be able to see that, because then your critical value becomes the area of rejection will be determined by that critical value. So anything that falls on the right of that critical value will be shaded, and you can call that the rejection area. And anything on the left, we call it the non-rejection area, or we do not reject if our test statistic falls within this area there. Okay, so let's look at an example of how we do this. So let's say we have the following sample of babies born in a city in 2015 by month. So from January until December, we have the number of babies that were born. And we want to test at 2.5% level of significance whether the number of babies born in this city are evenly distributed throughout the year. So we want to check if these babies born, or the number of babies born in this city follow a certain distribution. Are they distributed throughout the year? Okay, evenly. So the first step we need to do is to state our null hypothesis and our alternative hypothesis. Stating our null hypothesis will say the number of babies born in the city is evenly distributed throughout the year, or we can also say the number of babies born in the city fit the evenly distributed distribution throughout the year, something like that. The alternative will state that the number of babies born in a year is not evenly distributed throughout the year, and that is the alternative. After that, we need to calculate the total, because if you look at the table that we have, we will need the total. So if you get the table like this, and we know that we're doing the chi-square test, we get a table that looks like this, and it does not have a total. Quickly calculate the total at the end, and you just add an extra column there and say it's total, and then you add all of those values, you add all of them, and that will give you your total. So the total of all these babies born in this year on that year is 252. Good. The next step is for us to calculate the probability, because they haven't given us the probability. If they would have given us the probability, which is the p-value, it would have been easy. Then we can calculate the expected value. But since they didn't give us the probability, we can calculate the probabilities. We know that January has 31 days. So if we know that January has 31 days, to calculate the probability for January will be 31 days divided by 365 days. And that will give us the probability of January, which will be 0.0845 some number. So you need to write all of those numbers down. And we can also calculate the probability for February, which will give us 28 divided by 365. The probability for March will give us 30 days divided by 365 will give us all those probabilities. And I have all the probabilities. And since it's easy, I know which months have the same days. I can just populate my probability and then calculate. I now need to calculate the expected value. Calculating the expected value, we need to take this probability, multiply by the grand total, which is 252. So what we do, we say 0.85, or actually it's 0.0845 and some number multiplied by 252 will give us 21.40. If you take this rounded off number, you will not get exactly the same answer. So on your calculator, when you do this, make sure that you keep all the decimals so that you do not round off quickly and you have the exact value so that you can find the answer when you look at the answer sheet. So keep all the digits. So you calculate the expected values for all of them, as you can see, for all, because January, April, June, January, and March, May, July, August have the same number of days, is 31, 31, 31, 31. So on those days, I can only calculate for January and then populate the rest, and then do the same with not February, but April. April has 30 days. Oh, I kept on saying March has 30 days. March has 31 days. April has 30 days. So from April, June, September, November, they have the same days. So I can just calculate for April and then take all the values for the other months as well. And then I have my expected value. And remember, my observed value were those ones that were given to me in the beginning. Now I need to substitute and calculate my test statistic. Remember the test statistic formula? The sum of your observed value minus your expected squared divided by your expected. I know here I have my answer, but just to show you what you need to be doing, you will say, because this table is big, I'm not going to do all of them, but you're going to say 24 minus 21.40, and you're going to square the answer and divide by 21.40. Then you add the next one and say 23 minus 19.33 divide, square, must not forget the square, divide by 19.333 plus, and you do everything until you get to the last one, which is 29 minus 21.40 squared divide by 21.40. So you will have to do for all of them and then work it out for all 12 months and find the answer for every one of them and add them and add all your answers. And once you have added all your answers, you will get that the chi-square statistic is 7.72. In the exam, they will not give you this long table. They will give you a short table, or they will give you 4 or 5 values to use. So do not worry and say, oh, but then it's going to take me forever in the exam to do this exercise. So this is just for an example. It's for the example purpose. Okay, so once we've calculated the test statistic, now we need to go and find the critical value. Finding the critical value, So we say, remember the critical value, we use the number of rows minus 1 times the number of columns minus 1. So how many rows do we have? Remember, not including the expected value. We only have 1 row of the observed values. And we have 12 columns. So we have 1 minus 1. Oh, sorry, my bad. We only say C minus 1. We don't consider the row, sorry. We consider the columns only. So the number of, so we only take the number of columns. Why do I put it as N? It should be C. Your number of columns, we have 12. So it will be 12 minus 1. And that will give us 11. And then we know, remember, we were given 2.25. So 2.25 is our alpha. So if we take 2.25 divide by 100, the answer we'll get will be 0.025. Therefore, our alpha will be 0.025 and a degrees of freedom of 11. Then we need to go to the chi-squared table. On the chi-square test, we're going to go on the chi-square table and find 0.025. And then on the side, we're going to find the degrees of freedom, which will be 11. I will show you just now where they both meet. Wherever they meet, that should be 2.21.92. So let's go and find . Let's go and find our critical value. Okay. So finding the critical value, we need to go find table 3, which is called the critical values of chi. And if we look at the critical values of chi, you will see that at the top it has the chi values, the alpha values. There is our alpha of 0.025, and we come here on the side and look for the degrees of freedom 11, where they both meet. That will be the value we are looking for. And I know that this is the 21.9. So in this instance, this table only has 1 decimal places. So it's still fine. You will be using this table. So you are going to say 21.9 is your critical value. And then we go back to the presentation. Okay, so we know that that is our critical value, which is 21.9. Then we're going to make a decision based on this critical value. So let's make a decision. So with this critical value, what we do, we can just draw the graph for chi-square distribution. And since it's a left skew, it's a right skew distribution, so I can draw it this way. Anything that falls that side will be rejected. So this is our rejection area, and this is our do not reject. Our critical value, we found it, it was 21.9, and we're going to take our chi-square test and locate it on this graph, and we can see that it falls somewhere on the do not reject. Timothy, can you see the presentation?
I don't see it, Miss Boyd. Maybe it's, I don't know, but I don't see it on my.
I'm going to Go back again. Share again the presentation.
Okay, yeah. Working now.
Okay, sorry, we were here. So I was explaining that you come here and you draw your graph. And in the side, it will be the rejection area. And on the other side, it will be your do not reject area, where your critical value will be your will determine your rejection area. So now we take the 7.72 and locate it. And if we do, we will find that it falls somewhere on the do not reject area. And that is why we fail to reject the null hypothesis. And this means that the data are not sufficient to claim that the number of babies in the city are not evenly distributed throughout the year. That's how you do the tests. And how you do your hypothesis. Any question?
Miss Bui, can you just go? I understand everything, not everything entirely. I just don't understand how you got that expected value of 221.40 for January. Can you go back to that slide for me so that I can check it out?
So since we were given the observed values with no total, I calculated the total. Then to calculate the probability, like I said, the probability, they will give it to you in the exam, or if they do not give it to you, you need to know that for a calendar, a probability will be the number of days. If it's a die, let's say they give you an example and they use a die. A die has 6 sides. So to get one outcome, it will be 1/6. So it will be 1/6 for all of them.
Okay.
And then for this one, because January has 31 days, February has 28 days, March has 31 days, April has 30 days, and so forth and so forth. So you just use those days to calculate the probabilities. But otherwise, they will give the probabilities. They will say probability for 1 will be 0.6. Probability for 2 will be 0.4. Probability for 3 will be 0.1. Probability like that. So they will give you all the probabilities, but it will not be like this. So mine is even over the set probability. So let's say that is 0.2 and then so forth. Something like that. Okay, so let's look at, let's do one last more example with you. So it's one of the exercises that I have. So this is the example. So they say, given the null hypothesis stated, so the other thing, the probability will always be in your null hypothesis because we are using the probability as your population probability as well, as part of the population. So you will know your probability from there because you do not know your probability for the sample. So for example, now you are given, we are given all these values and they say the observed values are below. So the null hypothesis is stated there. So we need to test if this distribution is follows the same distribution for all the P's, and then the alternative will say they are different. So at this moment, we'll say the variable differs from the given distribution that we are given. Then we need to test this. But in the exam, they will give you, like, for example, the values in this instance, like they give them to you as an option. So these are the same as your hypothesis testing steps that I just did. But in this instance, there are options where you need to use each step to find out whether one is correct. So the sample size N is 100. So what they're asking you is the total 100. So that's what they are asking you. So it means you need to add all of these values. So please add all the values and tell me if they are 100, because we're doing this exercise together now. So it's 39 plus 78 plus 64 plus 90, which is 200. And you see there, it said it's 900. So then this is not correct, because the total there is 200. So I must write that total is 200. Now, it says the expected frequency are 40, 80, 60, and 20. We need to take those probabilities from the top, from the hypothesis, and use them as our probabilities and multiply every probability. For P1, it corresponds to 1. P2 corresponds to 2. P3 corresponds with 3. P4 corresponds with 4. So what we do, it's say 0.2 multiplied by 200. And we have to test for all of them. Is that correct? That is correct. It's 40. Then you do the next one. 0.4 multiplied by 200. And that will give you 8. That's correct. Then you do the next one. 64, oh, not 64. 0.3 multiplied by 200. What you get? 60. That's correct. Then 0.1 multiplied by 200. And you get 20. So option number 2 is the correct option. But let's say option number 2 is not correct for the argument's sake, and continue with the rest of the exercise. So now we have our expected value. The next thing they're asking is the rejection area. They say the rejection region at 5%. So it means our chi-square alpha and the degrees of freedom, which we know that our alpha at this point, chi-square, our chi-square alpha, they say it's at 5%. So it will be at 0.05. And the degrees of freedom is, remember, the degrees of freedom is the number of columns minus 1. So our degrees of freedom is number of columns minus 1. How many columns do we have? We have 4. So it will be 4 minus 1, which is equal to 3. And the degrees of freedom will be 3. So you go to the chi-square table. If you go to the chi-square table, you look for 0.05 at the top. 0.05, it's from the left, it's 1, 2, 3, 4. It's column number 4 from the left. Then we look for 4. I'm not sharing the screen at this point. I'm not sharing my screen for this, so I'm expecting you to go to your tables. What do you see there? So you go at the top, you look for 0.5 at the top, and then on the side, look for 4. No, we're not looking for 4, but we're looking for 3, because the degrees of freedom is 3. So look for 3. So you go to 3 where they both meet, like we did with the first exercise, where they both meet. What do you see there? What is the critical value you see there? Are you guys doing the exercise? Did you find the critical value? Should I share my screen? You have your tutorial.
Please share your screen. I don't have my graph with me now. I'm in my table.
Okay, and there is the table. You can make it bigger. So go at the top, look for chi-square 0,05. So it will be 0.05. Column number 4 from the right. And then on the left, going down, look for 3 where they both meet. Tell me what value do you see?
7.81.
That will be your critical value. So
Okay,
going
just
back,
correct.
yes. So as you can see, I think this past exam paper had an error somewhere. Can you see the presentation now? I'm back at the presentation.
No. Yes. Now it's visible.
Okay. So then it means option 3. Oh, sorry. Option 3 is also correct. The other question they're asking, the critical value is 7.18. Oh, sorry. No, we're not reading the question. I wasn't able to read the question. So we found the critical value is 7.18. The question is saying we're going to reject the rejection region at 5% for level of significance is chi-square 7,881. So where will be the rejection region? So we know that if we draw this, it will be, the rejection region will be at that point. So that will be our 7.81. So it means it is correct in that way. So the next one, it says the critical value is 7,18. Is it correct?
No.
It's not correct.
Yep.
Then the last one, it says the test statistic is 0,9371. So what they are expecting you to do there is to calculate the chi-square test statistics. So let's do that. So remember the formula, chi-square stat is given by the sum of your observed value minus your expected value squared divided by your expected value. Remember that? So now we know what our expected values are. We calculated them. Know our observed values are. We calculated them. So what you're going to do, you will have to give me the answer. So you're going to say 39 minus expected value of 40 squared divided by 40 plus, you continue, 78 minus 80 squared divided by 8. So I'm just going to leave it to you to complete the whole exercise.
Okay. Okay, I'm getting the answer as 0.1516,
Okay.
which is 152.
Okay, so you did all of this until the end because I don't have that.
Yes.
So I'm just writing all the answers here that I have. So 19 minus 20 squared divided by 20 equals
0.05.
0.05. So if you add all of them, 0.025 plus 0.05 plus 4. Did I do it right? Sorry.
No, it's not 4 point, it's 0.267.
Yes, so I just realized that one I did it all wrong. 64 minus 60 squared divided by 60 is
0.2666.
0.26. Let me just leave it to 67. 0.25, 0.025, 0.025 plus 0.05 plus 0.267 plus 0.05 equals 0. What do you get?
I got 0.152.
Huh?
Yes, I think somewhere you made a mistake where you added it's 0.025 plus 0.05 plus 0.267 plus 0.05 again.
Okay. Huh. Why are we not getting the same answer? So
I don't
my
know.
answers right there at the top. So
Yes, they are
they
right.
Okay, so if they are right, then you should get 0.3.267. What do you get?
0.152.
You cannot get 0.15 if there is 0.26. Unless you are adding 0.026. Recalculate.
Okay, I'm adding 0.05 now. Okay, let me start from the left side. 0.025 plus 0.05.
Yes.
Plus 0.266. plus 0. Okay. Okay, it's my bad. 0.392. Now I was adding that 0.267 as 0.0267. It's my bad.
Yes.
So the answer is 0.392.
Yes, I think they wrote this wrong. I don't know what's wrong with this question, whether they were looking for the incorrect answer or they're looking for the correct answer. But so far we have that question wrong, that question is wrong, and that question is wrong. Unless then by means of this, they assume that we do not reject unless then they made a mistake when they make this conclusion there for the rejection region, because the rejection region will be on the bigger side of 7.81. Since it's the chi-square distribution, this side will be your rejection area, and this is your bigger side of the rejection area. So, yeah.
Okay.
This is correct as well. So between the two, I don't know which one they expected you to say is correct or incorrect. Okay, so we have 3 minutes before the next question. I have another question. This one, they also asking you to calculate the critical value and also the test statistics. So
Okay.
critical value, remember, you go find it on the table. So there are 4 columns and it's at 5%. So it's the same as what we just did. So I don't expect you to go and calculate it again because we found the same answer because there were 4 columns and at 5%, it was 7.81. We know that one. So all I want you to do is calculate the test statistic. So your chi-square set, you just need to calculate that. 0 minus E squared divided by E. That's all what you need to be calculating. So, but before that, you need to calculate the expected values. So maybe at here, expected values, and say the total. But we know what the total is. It's 150. So I already said 38 plus 50 plus 38 plus 24 is equals to 150. So all what you need to do is say 0.15 multiplied by 150. And that will give you your expected value. Which then this is 22.5. And 40 multiplied by 150. And that's 60. 3F multiplied by 150. And that is 52.5. So you'll do for all of them and 0.1 multiplied by 150. And that will be 15. Now you have your expected values. You can just substitute them into the formula. It will be 38 minus 22.5 squared divided by 22.5. And we do the same for the rest of them, which will be 50 minus 60 squared divided by 60 plus 38 minus 52.5 squared divided by 52.5 plus 24 minus 15 squared divide by 15. Then we can solve that. I will do it quietly and write the answer. You can also do it so that we can check our answers together as well if we get the same answers. Because we rounded off quickly as well, we might find some challenges. Are you winning? So if you leave all the digits, you should get the correct answer. 7, 4, 9, 2, 4, 4, 3. There are 4 3s. 3 4s. Okay. Are you winning? Do you have the same
Yes.
Answers as me?
I have the
So
same answer, yes.
Yeah, when you do the calculations, please pay attention to the number of digits that you leave. Don't round off quickly, like I have rounded off there. So for example, that answer 38 minus 22,5 squared divided by 22,5, it is 10,6777777. Keep all the digits. And 50 minus 60 squared divided by 60, it's 1,666666666. Keep all the digits. And 38 minus 52.5 squared divided by 52.5, it's 4,04 some number. Keep all the digits. And 24 minus 15 squared divided by 15 is just 5.4. If you add all the digits and you add them together, the answer will look almost similar to the one that I have. I rounded off 4,0048. So you might not get the same as I am, but at least the answer will be on the answer sheet. Sorry about that. And that gives us, for some reason, I cannot write. And this, if we round it to 4 decimal places, the answer is 21,49. 21,747492, which makes option 1 the correct one. So I'm just gonna go through this slowly so that next time you want to check the additional examples or exercises for practice, then you can go through them. All these questions comes from your past exam papers that we are doing. So if we're doing the preparation, you can go through them. They will help you to prepare for your exam. So when you watch the videos, you can pause and do the exercise and see if you get them right. There was another question from another past exam paper. Here it just asks you about the expected frequencies. We just need to calculate the expected frequencies. So the first thing you do is calculate the total, but you don't have to because they gave you your n. Then the last one, so it was the last exercise that we were supposed to be doing. So it's fine. So let's move on to the next section. Remember, so far we looked at the confidence, the goodness fit test, which it means we're looking at we're looking at numerical value. We're calculating the chi-square test for numerical value. Now we're going to look at how we calculate the test for categorical values. So here we're calculating the chi-square test for independence, and we're going to be using a contingency table, which means we're taking 2 categorical variables like we so we take the 2 categorical variables and we want to test if one is dependent on the other or independent of the other one. One is related or not related to the other one. And that's what we're going to be testing. So for chi-square for independence, we use 2 categorical variables. So when we state the null hypothesis, we're going to state that, sorry, 2 categorical variables are independent. They have no relationship. And we always state that they are independent. The null hypothesis always states in the null hypothesis, they are independent. The alternative will say the opposite. It will say the two categorical variables are dependent. It means there is a relationship between the two of them. To calculate the test statistic, we use the same formula. It's for the chi-square test. Observed values minus expected squared divided by the expected, and it's the sum of all of those values. Now, because we're using a contingency table, we need to also bear in mind that with the contingency table, it has the number of rows and it also has the columns. So to find the critical value, we're going to use the degrees of freedom of number of rows times -1 times the number of columns -1 and the alpha level of significance. And I'm going to show you at the later stage how we find the critical value for this one as well. The expected value as compared to the previous one where we use the probability, with this one, we calculate the expected value using the totals of the contingency table and the grand total. So to calculate the expected value for each observed value, we use the row total of that observed value times the column total of that observed value divided by the grand total. So if we have a contingency table that looks like this, and it has males and females, and here we have what can I write there? You are a Capetonian, or not a Capetonian. Let's put it that way. So when you have a contingency table to calculate the expected value for this joint probability there, so to joint event of female and Capetonian, we need to calculate the total. So we'll take this total and we'll need to calculate the total there, and we'll have to add all of them and calculate our N. So we will take the row total, multiply by the column total, divide by your sample size. And I will show you how at the later stage now. Once we have the test statistic and we found the critical value, then we can determine our rejection area. Remember, it's still the same. You can draw the graph and define your critical value, which is the test statistic with the degrees of freedom, which then this side becomes your region of rejection, and on the white side, it becomes the non-region of rejection. And once you have that, you can make your decision. So let's look at an example. If we have the meal plan selected by 200 students shown below, we have the class standing and the number of meals per week selected by the student. And there were about 200 students, so freshmen selected 24 meals for 20 weeks. And the Sophia, they selected for 10 weeks. There was 26 people who selected 10 weeks. Okay, so now let's test the hypothesis. We want to test if class standing and the number of meals are related. To state the null hypothesis, meal plan and class standing are independent. Alternative, meal plan and class standing are dependent. Now we need to calculate the expected value, because when we calculate the test statistic, we will need to calculate the expected frequencies. So if we want to calculate the expected frequency for 24, we're going to go to the row total of 24. So we want to say the row total is 70 multiplied by the column total, which is 70, divided by your N, which is 200. And that will give us 70 multiplied by 70 multiplied by 70 equals 4,900 divided by 200. And the answer I get is 24.5, which is that frequency. And you do the rest of the table. So for example, to calculate the frequency for the blue cycle, the circled one, you can see there, we take the row total. The row total is 30, the column total is 70. So it will be 30 multiplied by 70 divide by 200. And you will have to do for all of the values so that you can get the expected values, and you calculate the expected values for all of them. Once you have the expected values, you can go and substitute them onto the statistic formula. So you take your observed minus your expected squared, divide by your expected, plus observed minus expected squared, divide by expected, and you do for all of them. Then you go and find the critical value. The critical value, we find it on alpha and the degrees of freedom. Now, our alpha in this instance is 0.05. So critical value of 0.05 and the degrees of freedom. So degrees of freedom for this, we said it's number of rows minus 1 times number of columns minus 1. So how many rows do we have? If we go back, if I look at the observed values, we have 1, 2, 3, 4. So there are 4 rows and 1, 2, 3 columns. There are 4 rows, 3 columns. So to calculate this, we say there are 4 minus 1 and 3 minus 1. Sorry about that. Okay, so then it is 4 minus 1 is 3 times 3 minus 1 is 2. And this will give us 6. Then you go to the table. Go out of this and go to the table. We go find the table. So the same thing that we've been doing. So we locate the critical value by just going through the same process. Where is the table now? Okay, found it. So remember, we're looking for alpha of 0.05 and the degrees of freedom of 6. So we go 0.05, 0.05, and we look for 6. And 6 is there. Where they both meet. Sorry, my hand is shaky. And that is 12.6. And that is our critical value. So the same method that we used previously, we still use the same to find the critical value. Okay, and that is our critical value, 12.59. And once we have the critical value and we have our test statistic, we calculated our test statistic and we found that it was 0.709, then we can make a decision. We know what our test statistic was 0.09 and our critical value was 12.59. We draw this, we find our region of rejection. Anything that falls this side, we reject. Anything on the white area, we do not reject. If we look at 12.5 is there, that's our region of rejection. And 0.7, it falls in the do not reject. We do not reject the null hypothesis, and we can conclude that there is not sufficient evidence that the meal plan and class standing are related at alpha 0.05. And that's how you make the decision. Now we can do the exercise. Do you have any question? If there are no questions, then we will do an exercise. Okay, so in the absence of questions, I know the question is asking you to calculate only one expected value. I want you to calculate for all of them because we're going to use them at the later stage. And then once you have calculated your expected values, you can then answer the question and then we will move to the next one. So, but for now, what I expect you to do, step number 1 on this, I expect you to complete the whole table. So number 1, complete the table. So it means where you see the missing blocky and the question mark, make sure that you calculate all those values. How do you calculate the question mark? Because this is a total, it means if I subtract 56 from the total, I will get the value there. Then also the same, if I subtract the total from here, 181 subtract the total of 122, I will get the value there. Or you can add both of these values and get the answer there. So it's up to you how you want to do this, but I expect you to complete the whole table. Once you have completed the whole table, step number 2, calculate the expected values, not only for the answer, but for the whole table, because we're going to use it at a later stage. Calculate the expected values. So on a piece of paper somewhere, write the expected values there. And once you have calculated the expected values, then we answer this. You have 5 minutes. When you're done, please let me know that you are done so that we can move on to the next. Let's work together. You must let me know when you are done.
Yeah, I'm done. Say the answer.
Yes. Give me the answer for female.
For female is 66.
And total for no.
For no, it's 59.
It's 59. And total for male.
It's 79.
And total for female.
It's 102.
102. So now, since we have all this, we can calculate the expected values. So did you calculate the expected value for all of them? I'm not going to worry about them. So I told you to calculate for all of them. Remember that? For 56, for 66, for 23, and for 36. But for now, I want you to give me the expected value for yes and female. For yes, female is 66. So the expected value for 66 will be the row total, which is 122, multiplied by the column total, which is 102, divided by your n, which is 181. Did you do that? What was your answer?
68.75.
68.75, which is option number 3.
3.
Okay. So remember I told you, calculate all the expected value. Your next exercise for 5 more minutes. Calculate the test statistic. So if you have calculated your expected values, so you should say the expected value for this one. So you can draw another table close by, because you only need 2 columns and 2 rows. So for yes and for no, you would have calculated male and female, and you say 66 point, what did we say? 68.75. So you need to complete this whole table. Once you have completed this whole table, you need to calculate your chi-squared state, which is your sum of your observed minus your expected squared divided by your expected, which means you're going to say 56 minus whatever the expected value there was. So I don't know what the expected value is. Squared divided by your expected value, and you do the same. That one, we said it's 66. So 66 minus 68.75 squared divided by 68.75. Plus, you continue. I am giving you 10 minutes on this one. I will check up on you at 10:43. Okay, 2 more minutes, unless if you are done.
Yeah, I'm done.
Are you still busy or you are finishing off?
I'm finishing off.
No, I've completed it. Can I give the answer?
Let's give those because we still have 2 more minutes. Those ones who are completing it off. You will have to guide me, guys. Those two we said they're still busy. You must let us know when you are done so we can continue. One minute. Okay, can we get the answer now? Anybody?
Okay.
Pardon?
Okay.
It's option.
I'm just doing only these two to save time. Okay, so because I didn't calculate the rest of the other expected values, so I expect you to give me the answer. So for 23, what was the expected value?
Okay.
25.75.
25.5.
25.75.
Yes.
Yes.
And for 36? Oh, sorry.
It was 33.25.
33.249.
Okay, we can leave it at 2.45. 25 squared divided by 33.25. So give me the answers for every one of them. The first one, 56 minus 53.25 squared divided by 53.25.
0.14.
0.14.
It's
It's just 0.14.
no,
All the decimals.
0.14212.
Yes, all the decimals.
Yeah, I try to keep 5 of them.
It's fine. Next. 66 minus 68.75 squared divided by 68.75. What do you get? Guys, I thought you calculated it. You should be just giving me answers. No answer. Are you still calculating? Oh, yeah. 56 minus 53.25 equals squared. Divide by 53.25 equals 0.1420. The next one plus the next one plus the next one. And you will find the answer. Because I'm trying to help you here. You are not responding to me. And this is your assignment question. So I cannot give you all the answers you need unless if you work with me.
It's option 4.
Okay. So you would have calculated, because I was waiting for the other answers in between so that we can get to the answer that you have there as option 4. But if you haven't calculated all of them, okay.
0.9.
Your line is bad.
Yeah, calculated by all the digits.
Yes, but your line is bad for now.
Now, Miss Boy, can you hear me?
Yeah, now I can hear you.
Miss.
Yes, I can hear you. Okay. Now find the critical value. Using the same information at 5%, what will be your critical value? Remember then now your critical value is given by chi-squared alpha, which is 5%, will be alpha and your degrees of freedom. And we know our degrees of freedom is the number of rows minus 1 times number of columns minus 1. Do you have your critical value?
It's 3.84.
It is 3.84 because when you go to the table, you will find your chi-square of 0.05 and your degrees of freedom will be the number of rows, there are 2 minus 1. The number of columns, there are 2 minus 1. And that will give you your degrees of freedom of 1 multiplied by 1, which is 1. When you go to the table, you will look at the top for a chi-square 0.05 and 1. Where they meet, it will have 3.84. And that's how you answer the questions on chi-square test. Then I guess maybe probably the last question was, how do you reject the null hypothesis and so forth? That's for you to go find out on your own. That was the 3 questions from your assignment. I don't know when was your assignment due. So this is another example coming from another exercise coming from your past exam paper. We have 10 more minutes. I just want to give you high hints on how to tackle this kind of questions. So they save you time because they calculated your expected frequencies on this one. All what you need to do is make sure that you understand how the other things work, how to state the null hypothesis, because that's what they're asking you to state there. Is question 1 correct or incorrect? So remember, the null hypothesis, we always state that they are independent. So then when it says independent, it means they do not have a relationship. And the alternative will say they are dependent. So it means there is a relationship. So is that one correct or not correct? That's how you're going to answer those questions. The degrees of freedom, remember?
It's incorrect.
It will be incorrect. The degrees of freedom is number of rows minus 1 times number of columns minus 1. Is that the degrees of freedom? So there are how many rows, how many columns do they have? Do not count the total. So that's what you need
incorrect.
to do there. Yes, it's incorrect because how many number of rows do you have? You have 2 rows minus 1, and you have 3 columns minus 1, which is 1 multiplied by 2, and that will be incorrect. The next thing they're asking you to find the critical value. So you're going to go find the critical value of 0.10 and the degrees of freedom of 2. So you go to the table. Is it that correct or incorrect? You go to the table, you look for 0.1. It's 10%, so it's 0.1. 0.1, which is 0.100. So you go to that column and you go to 2. What will be the critical value? You will go to correct?
9.21.
Nope. Sorry. Sorry, I didn't hear you.
It's let me check. 9.21.
9.21.
Yes.
Are you saying 9.21? Is that what you are saying?
Yes, that's what I'm saying.
Did you go to the chi-square 0.1, which is 0.100? Don't go to where it says 0.1 because 0.1 is 1%.
Yeah. Oh, check.
You must go to 0.1, 10%. 10 divided by 100 is 0.1. So you just go to where it says 0.1 and 2. What is the critical value there?
Oh, it's 4.61, yeah.
And that would have been the correct one. And the next one, they're asking you to calculate the test statistics.
Yeah.
So you will have to go and calculate the long calculation. And after that, you can make a conclusion and a decision. So, but we already found what we were looking for. I'm going to stop right there. But if that was not the right one, then you will continue and look at the other options. This is another type that comes from your past exam paper as well. So here, also easy. They're asking you to find the degrees of freedom, what will be the expected frequency, and what is the critical value. And is that how you state the null hypothesis? Look at what they wrote there. Is it correct? Nope. And here they're just asking you to validate whether you know that this is the observed value, is it correct or wrong? And you are looking for the correct answer. And those are the type of questions you will get in the exam as well. And that, with this 5 minutes that is left, let me just conclude and recap. So far, we've looked at chi-square for independence and chi-square for goodness fit test. Remember, when we do chi-square for goodness fit test, you will be given the observed value for the numerical values. You need to calculate the probability, or they will give you the probability as part of your hypothesis testing. Then, to calculate the expected value, you need to take your probability, multiply by the grand total, so that you can get the expected value for every value that you have. Then you calculate the test by substituting the value of your observed minus your expected squared divided by your expected, and you add all of them up. To find the critical value, this is for the chi-square, you're also only going to use the alpha and the degrees of freedom. And the degrees of freedom is the number of columns minus 1, and you go find the value on the table. Then the critical value will give you the region of rejection that you will use to make your decision. If it falls in the rejection area, or it's greater, if your test statistic is greater than your critical value, you reject the null hypothesis. That is for goodness fit test. For contingency table or for independence, you will be given a contingency table, which is a cross-tabulation table. You will need to calculate the expected value by using the row total multiplied by the column total divided by the grand total. And that will give you your expected value. To find the critical value, we use alpha and the degrees of freedom. And the degrees of freedom is the number of columns minus 1 times the number of rows minus 1. And you go to the table like we do with the goodness fit test. We go to the table, we locate the critical value, and we create the region of rejection with the critical value. If it's bigger than the critical value, if your test statistic is bigger than the critical value, you reject the null hypothesis. Otherwise, you do not. And that concludes today's session. Before you leave today, please complete the feedback form. I'm going to post it in the chat right now. Just give me some few sec. And there is your feedback form. And I don't know why Jacques said you must write your student number in the chat. Here is the link to the register. Please make sure that you also complete it on the register, and the first link is the feedback form link. If there are no questions or comments,